beautiful people, and welcome. In today's video, we will be writing parallel and perpendicular equations. I'm going to give you all the steps necessary to how to do this very effortlessly. It's not going to be too complicated, I hope, but we're going to find out in this video. As always, disclaimer, if I make a mistake, I am human. It is okay to make mistakes as long as you learn from your mistakes. That way, we learn. I learn, you learn, so let me know if I make a mistake so that way I can fix it. If you hear any noise in the background, we are recording from home. Miss Sylvanas is being a kitty in the background. That is her if you hear anything. All right, let's get started. So writing parallel and perpendicular equations. If you have not already watched the introduction video for parallel and perpendicular lines, go ahead and head over there and watch that first. Here we're just going to be talking about how to write parallel and perpendicular equations. So you should know what the requirements are for both. Okay, step number 1, and I'm just going to jump into steps. And let's actually work with an equation. Let's work with an example. And so that way you can see each step applied. So let's start with an example. So let's say we want to write an equation parallel to y equals 2x plus 4 that passes through -4, -1. So that's our question, okay? That's our task, our objective. Our objective is to have an equation that is specifically parallel to y equals 2x plus 4. So I'm going to actually point out some keywords. First keyword here is parallel. Super important we know what we're doing. We want an equation that's parallel. We are given an equation and we are given a point. So 3 pieces of very valuable information. Okay, so step number 1 is you're going to use the point slope equation. Now, if you're freaking out right now, thinking to yourself, well, I don't know what the point slope equation is. Don't worry, I'm going to let you know what that is. That is your y minus y1 is equal to m parenthesis x minus x1. If you are in my class, we are using our keep change on this equation. So keep, we're changing our m1. We are changing our m, which is our slope. We are keeping our x and minus. And once again, we are changing our x1. So again, keep change. So step number 1 is use the point slope equation. So let's do that. Okay, step number 2, that was step number 1. Step number 2, substitute the slope. Let me actually back up. Substitute the slope and the given point. Okay, before you start plugging anything in, the slope, recall this. If you want parallel, if you want a parallel line, you're going to keep the slope the same. If you want a perpendicular, You want your opposite reciprocal. So before you plug in anything for the slope, you have to ask yourself, what do we want? What's our objective? In example number 1, our objective is to find something that is parallel. So for parallel, we want to keep the slope the same. So what is the slope? Well, we're going to look at what is given and identify what our slope is. In this equation that they already provided to us, we know this is in slope-intercept form. So our slope is 2, whatever is in front of x. Again, if it's in standard form, use the equation to find your slope in standard form. Okay, so step number 1 is done. Step number 2 is you're going to substitute your slope and your given point. So remember, always label your point so you don't make silly mistakes. Let me actually get another marker. So keep, change. Change your slope. Again, we're keeping the slope the same because we want something that's parallel. Keep, change. So then we have y, if you can circle it, makes it a plus. Y plus 1 is equal to 2 times, if you can circle it, it makes it a plus. X plus 4. And then so after that, step number 3 is distribute and solve for y. So basically we want it in y equals mx plus b format. So let's do that. Let's distribute and solve for y. So I have y plus 1 is equal to 2x plus 8. I'm going to solve for y by subtracting 1 on both sides. Y equals 2x, here's my dotted line, plus 7. So it's asking us write an equation parallel to this equation that passes through this point. So here it is. Here is my final answer. So what that means is these two lines are parallel, but this specific line, if I was to graph it, goes through this point here. Okay? Let's actually, I'm going to pause it right here. I'm going to show you how this looks like on a graph. All right, beautiful people. I am here on Desmos.com. If you ever want to find anything graphing related, go ahead and go to Desmos.com. It's fantastic. I'm going to type in my original. I have y equals 2x plus 4. That's my original line. Now I'm going to make sure that my answer, my final answer, is parallel to that line. That means they will never meet. There you go. And then I just want to show you that that blue line right there should pass through the point -4, -1. So here it is. Here's my point -4, -1. Here's my blue line that we have created. And this blue line is parallel to this red line. The red line was our original. So that is our objective. Our objective in in example number 1 is to get a line that's parallel to the red one, but also goes through this specific point. So we have done that. All right, let's go ahead and move on to example number 2. All right, so now we're on example number 2. And then for example number 2, let's work with something that's asking us to find something that's perpendicular. So write an equation. Perpendicular to 5x plus 3y is equal to -21. That passes through -5 and 1. Again, highlight, circle, do whatever you need to do to know your 3 pieces of information. So super important is to know that you're looking for something that's perpendicular. Here's your given line, and here's the point that we want our new line to go through. I'm still using the points that we used, not points, we are still using the steps that we used in example number 1, but our steps are going to be just slightly modified to fit this equation that is given to us in example number 2. So step number 1, use point-slope equation. Where am I getting my steps? I'm getting my steps from here. So step number 1, we want point-slope form. Y minus y1 equals m parenthesis x minus x1. You can't really see that, so I'm going to change my marker. There we go. Remember, it's keep, change. So I'm going to change my y1. I'm going to change my slope. And I'm going to change my x1 to whatever that is. Step number 2 is substitute the slope and the given point. So I don't know what my slope is in this line, but I do know what my given point is. So I'm going to identify my x1 and y1. So y1 is 1. x1 is negative 5. Make sure you bring the sign, and also make sure that you're putting parentheses so you don't actually change your minus. Remember, keep, change. So keep, change. Okay, now we need to figure out that slope. This is where I said we're going to just alter our steps from example number 1 just slightly to fit example number 2. So if you are given a standard form equation, I'm going to bring back our steps from our previous video, not necessarily steps, but just our graphic organizer. So if we have a standard form equation in this form, ax plus by equals c, you can find the slope in 2 different ways. You can solve for y and put in slope-intercept form, so make it look like y equals mx plus b. You can, and then you can find your slope, whatever is in front of x. Or you can find your slope by using the formula in standard form of your opposite a over b. I choose to do the opposite a over b. I feel like doing this is too much work. That is my opinion. You can do it. This is 100% okay. I choose to do this. The downside of this is you have to memorize the opposite a over b. If you don't have this memorized, sorry, you're out of luck. But this will always work. If you solve for y, maybe make this your backup plan. If you don't remember this formula, just solve for y. But in this case, we have our notes in front of us, so I'm going to say, in order to find our slope, so I'm going to put a thinking bubble here. So we're going to find the slope of 5x plus 3y is equal to 21 negative. So here's our ax plus by equals c. So we want opposite of a over b. So opposite over a is 5, b is 3. Always take the sign with it, positive. So then what is our slope? Our slope is negative 5/3. So that is our original. Okay, so that's our original slope. Now, before you start plugging anything in, take a step back and ask yourself, what is our objective? Our objective is to find a perpendicular line. So we want perpendicular slope. So if this is our original slope, we're not going to plug this one in for m, because that's not what we want. We don't want something that's parallel. So parallel means same slope. Perpendicular means we want the opposite reciprocal. Okay, so opposite of our original slope. So our original is negative 5/3. So the opposite of a negative 5/3 would be a positive. The reciprocal of 5/3, again, we're taking that fraction and we're flipping it. So the 3 was on bottom, now it's on the top. 5 was on top, now it's on the bottom. So this is your new slope. Your new slope is what you're going to plug into here because we want something that's perpendicular. So new slope is 3/5. And then now we're back to the original steps here. Step number 3, distribute and solve for y. So let's distribute our 3/5. So I have y minus 1 is equal to 3/5 x. Again, if you can circle it, makes it a plus. Distribute our fraction. Don't let that scare you. Just write it out. Y minus 1 is equal to 3/5 x plus 3/5 times 5. Remember, if it's a whole number, make sure you write it in the form of being on top. So y minus 1 is equal to 3/5 x plus, notice how you have a 5 on the bottom, 5 on top, and you're multiplying that these cancel out. And you have plus 3. Again, we're not done. We're trying to solve for y. So I'm going to add 1 to both sides. Here's my dotted line. So y is equal to 3/5 x plus 4. And again, did we do what it's asking us to do? Write an equation that is perpendicular to this equation that passes through -5/1. So let's go ahead and head over to Desmos again. There it is. I'm going to erase these to show our new equations. Okay, so our original equation was 5x plus 3y is equal to -21. And then my new equation was y equals 3/5 x plus 4. And then we want our new equation to pass through -5, 1. And I need to put parentheses since it is a coordinate point. Okay, so our original is the red. That's our original. Our new equation, that's the blue. And our new equation passes through the point of -5/1, and it does. And now this here, this intersection, because they are perpendicular, we know for sure 100% that this intersection between the red and the blue line, they meet at a 90-degree angle. So that's part of the definition of being perpendicular lines, or being perpendicular is that they meet at 90 degrees. But in this question, it's just asking us for the equation of line. So here it is. And let's go back. And we are done. Okay, so we have gone through example number 1 and we've gone through example number 2. One of them was a parallel, the other one was a perpendicular. If you have any questions, please let me know. Don't hesitate to reach out. If you've caught a mistake, as always, I am human, just let me know where the mistake occurred, and that way I can fix it. We both can learn from my mistakes. As always, thank you so much for watching. Like, subscribe, press that little notification bell, so that way you're notified when I post a video. Thank you again for watching, and I'll